Greetings from Dynamic Earth. Today, let's see our topic on minerals. We all know about what is mineral. A mineral is a solid constitution of crystal rocks, which is formed naturally and inorganic substances having a particular chemical composition or a range of composition and a regular atomic structure to which a crystalline form is related, or it should have a crystalline form. We all know about the composition of earth crust, which is made up of 99.33 percentage of those crystal rocks are composed of 11 common minerals. They are quartz, that is common silica dioxide, which comprises of 59.26 percentage, followed by alumina, calcium oxide, nitrous oxide, ferrous oxide, magnesium oxide, ferric oxide, potassium oxide, water, titanium oxide, phosphorus pentoxide, and the rest of 67 percentage is formed by all the rest of the minerals. There is a significant difference between element and a mineral. We all know that mineral is a solid inorganic substances which have a regular atomic structure and it should be in a crystalline form. But in case of element, it is a fundamental substance which can be broken into smaller chemical substances or chemical atoms, that is elements. And we all know that there are 11 common minerals that comprises 99.33 percentage of earth crust, and similarly there are 8 abundant elements which comprises 98 percentage of the earth crust, in which oxygen and silicon both comprises more than 3 by 4th of the total earth crust. Individually, oxygen has 46.6 percentage of total mass in earth. We all know that 21 percentage of earth atmosphere is comprised by oxygen, and mostly in the oxygen is abundant in the earth crust, which has 46 percentage. It is huge amount, but you can't separate that oxygen and you can breathe it, because it is combined with other minerals to form a oxide ores. We all know that we know that quartz is the single dominant mineral that comprises 59.26 percentage of crystal rocks, which is a form of silica dioxide, and next followed by alumina, which is aluminium Al2O3. So oxygen is not formed in the pure form under the crust, which is combined with other elements as well. So oxygen is followed by silica, aluminium, iron, calcium, sodium, potassium, magnesium, and these comprises 98 percentage, and rest of the element has just 2 percentage, and those 2 percentages are trace elements. And those trace element, the name trace element means which has a percentage of very minimal in that local. So for if you are considering the whole earth except these 8 elements, others are trace elements, but in a particular location. If we say iron is very less in that particular locality, we can also say iron is a trace element. It is not depend on the whole earth crust, it is depend on the locality. We can say if in a locality iron is abundant or rich, those areas are much suitable for mining activities, and some area it will, these elemental percentages is not common for all over the world. It can be changes from place to place. So we all know that there are 3 main parts in earth inner, which is crust, which is made up of mostly silica and aluminium, and mantle, which is made up of silica and magnesium, and the core is made up of knife, that is nickel and ferrous. These are all the dominant elements that are present in the earth composition. So let's back to minerals. To say an substance to be a mineral, there are some properties that it should be satisfied. They are one is it should be found naturally. If some minerals or some substances that are formed or that is produced in laboratory, that are not considered to be a mineral. The mineral should be formed naturally, and it should be inorganic, and it should have a solid state or solid state, and it should have a specific chemical composition, and it should be in a crystalline structure. For example, if it took quartz, it is naturally obtainable substance, and it is inorganic, and definitely it is a solid substance, and the chemical formula for quartz is Si plus O2, and it has a hexagonal crystal structure. like the properties, and the minerals also have some specific characteristics. They are physical characteristics, optical characteristics, and also chemical characteristics. We can briefly see about the physical characteristics in this video, and optical and chemical in later video. So there are 9 criteria for physical characteristics. They are color, luster, hardness, crystal form, and cleavage, tenacity, fracture, and specific gravity. So we will look one by one. First one is color. And all minerals will not satisfy all these characteristics. Some will possess some characteristics, and some will not have the specific characteristics, but it should satisfy any of these characteristics. So for example, if you took color, it is a physical characteristics. We can say quartz is colorless. If you see any colorless if you see any colorless crystalline rock, you can directly say it is quartz, and it can be have some color in between those colorless minerals, means it is termed to be an impurities. And then hematite ore, we can say that is also an ore of iron. Hematite is red in color, magnetite is black to gray in color, limonite is brown in color, and chalcopyrite is green in color. And these are all example. So minerals will have different colors. Then luster. What is luster means? Luster is the appearance of the surface of minerals in reflected light. Various type of lusters and respective minerals are pyrite, which has metallic while exposed to light, and quartz will have a glassy surface, opal will have a resinous, tal will have a pearly surface, and gypsum will have a silky surface. So next we can see about hardness. We all know about the relative hardness scale, which is created by Friedrich Mohs, an Austrian mineralogist. So he gave 10 scale hardness, 10 scale hardness, relative hardness scale, which can be used to compare different minerals hardness. We can say it is a 10 scale. First scale, it is a lower, it is talc, which can be scratched by our fingernail. Next one is gypsum. It can also be scratched by our fingernail, but with some strength. And the third scale is calcite. We can scratch with copper penny. And the fourth scale is fluorite. Fifth one is apatite. Sixth one is orthoclase feldspar. Seventh one is quartz. 8 is topaz, and 9 is corundum. 10 is diamond, which is the hardest element. By comparing these elements, we can distinguish the hardness of other element as well. So next physical characteristics is crystal form. We all know that crystal is solid body which has a definite geometric shape bounded by a planar surface arranged in a regular manner according to the internal atomic structure. And two things you need to know about crystal form. One is crystal faces, which is the planar surface bounded by a crystal is called as crystal faces, and the geometric arrangement of that crystal faces is called as crystal form. So there are 6 crystal forms that you can see. One is cubic form. In cubic form, it has a plane of symmetry is 9, which is maximum, and the axes of that crystal are 3 equal axes at right angle to one another. And the example is garnet and pyrite. And the second one is hexagonal form, which has 4 axes, 3 equal and horizontal, and is spaced at a equal interval. One vertical axis it has, and there are 7 plane of symmetry. The example is emerald. And now we can see about a form. There are 10 forms. Minerals in a cluster or a group develops various shape or form. So one is acular form, the fine needle-like structure developed with thin and sharp crystal of minerals. Okay, and second one is botryoidal structure, consists of a spheroidal aggregation resembling a bunch of grapes. The example for this is Chalcedony. And concretionary form is developed by detached means of either spherical or ellipsoidal or irregular shape. Example is flint noodles, or chalk is an example. And then dendritic form is developed in a thin joint and look like a tree or mosses. Example of this is manganese ore. And the Fifth one is reniform, which is air bubble like structure, and sixth one is tabular, and seventh one is granular, fibrous, radius, and resi are the other forms of crystalline minerals. So next, cleavage. What is cleavage? A mineral have a tendency to break in well-defined direction. So minerals will break in a well-defined direction and developed a smooth plane surface after breaking. This is called as cleavage. And the mineral break along the crystal faces according to the tendency of breaking. Mineral can be characterized with perfect, good, and distinct and imperfect cleavages are types of cleavages. Example for perfect cleavage is mica, good is potassium feldspar, distinct is calcite and fluorite mineral. So then fracture, the nature of the broken surface is called as fracture. There are four fracture types. They are conchoidal, which is curved fracture surface. The example is quartz and flint. And even fracture type is a fracture surface is nearly flat. Howlite as an example. Uneven is a fracture surface is rough. Most of the minerals will fall under uneven type. And Hackley is a fracture type is as a fracture surface contains sharp irregularities. Copper and silver is an example for this type of fracture. Then tenacity, the response of the mineral to the stress is called as tenacity. We can characterize them as malleable, brittle, sectile, and flexible. Malleable is gold and silver. Brittle, there is an example. Brittle, most of the mineral is brittle, which can be broken easily. Sectile is gold and silver, and flexible is mica, which is flexible, which can't be broken easily. So specific gravity of any matter is calculated with the formula of G is equal to W1 by W1 minus W2. W1 is the weight of the substance in air, and W2 is the weight of the substance in water. So most of the specific gravity the specific gravity of water is 1. So most of the mineral will have more than 2.16 to 6.9 or 7. So this is the physical characteristics of minerals. So we can see the optical and chemical properties of the minerals in the next part of the video. Thank you.